So students, today we're gonna be continuing our determinant series again. And this video is gonna be the last one of the series. In previous video, I probably did not have time to talk about two very important properties of determinants. So today we're gonna wrap that up and end the series here. I mean, not this series, this part of the series. The entire series is probably gonna be named after, class 12 mathematics. Okay. I don't know what would the order of this property that I'm gonna be discussing about today. But from the context of this video, I'm gonna be calling the first one that I'm gonna be preaching today is number one. And this one is gonna be very interesting. This says that if you have a determinant of any order, let's say a determinant of 2 by 2 order, A, B, C, and D. Now let's say the value of with this determinant is K. So this property says that if we swipe the rows or the columns of these determinants, the value would be negative of the value of the determinant would be the negative of its original value. So what does that mean? Is that replacing the rows B, D, A, C, or replacing the columns. So what are the same as it? This would be the same as replacing the columns C, D, A, B, and the value of this would be negative of its original value, so it would be minus K. Let me prove it actually. So the value of this determinant, the value of this one is AD minus BC. Okay. Now let's swipe the rows. It would become BD on top and AC on bottom. This would be BC minus BD. Sorry, BC minus AD. And if I factor out my negative one from this would become minus of AD minus BC. This is the same as the value of the original one, except it has it is negative of this one. And let's replace the columns. Let's swap the columns actually. It would be CD on this side and AB on this side. Evaluating this would give us again BC minus AD, and again factoring out a minus 1 from this would give us AD minus BC. Okay. So this is how this property works. This is gonna be really very interesting. And I think I have two more properties to talk about, and I'm going to link them to link the two of them together. The first one of them is that when we take a determinant, let's say we take a 3 order determinant with the elements A, B, C, D, E, F. D, F, G, H, I. So what I've told you guys in the previous videos of this series is that evaluating this would give us A times this determinant minus D times this determinant plus G times this determinant. Okay, you guys probably remember that. But this is not the only way you can evaluate a determinant. You can take any row or any column and do this with to that. What I'm basically saying is that you can let's say you decide to do this, read with this row, the second one. So you can evaluate this determinant from the perspective of the second row as well. It would be v times this determinant, except for these two elements, c and h, of course. Uh, then c times this determinant consisting a, g, c, and I. Then it is gonna be h times this determinant consisting a, d, c, f. Okay. What about the signs, you may ask? So this is where the concept of minors and cofactors come into play. You guys know how to find out cofactors of each element or determinant. When you evaluate the determinant from the perspective of any row or any column, it would work as well. You just have to write down the cofactors of those elements and we'll basically have to sum them up, and that is gonna give you, like, from regardless of which rows or which columns perspective you do it from, you're gonna get the same answer. And this is a really interesting property, and this is why the next property number 3, is gonna be really interesting to think about. If you ask me to prove this, it is that's gonna be really useless, I think. If you just take any determinant and try to perform this act onto that, like you try to evaluate this from the perspective of any row, any column, you find out that in every case the value remains the same. Okay. Now this is what makes the third property really interesting. The third property says that if in a determinant, if any row or any column consists only zeros, the value of the determinant would be 0. Let's say in this determinant, the second column consists only zeros. First one is ABC, second one is only zeros, and third one is GHI. This one would be, evaluating this would give us 0. You can find that out why that would be, because of calculating this, as I've taught you guys from the perspective of the first row as well. But I would say a better way to think about this would be trying to evaluate this. I've told you guys that evaluating this determinant would from the perspective of any row or any column would give us the same result. So instead of evaluating this from the perspective of the first row, you can evaluate this determinant from the perspective of the second column as well. And since all the elements of the second column are zeros, so when you find cofactors of them and multiply them with these elements themselves, which are all zeros, you just get 0, and summing them up all together would give us a 0 again. So this is why this property is really interesting, and like in exams this really comes in handy, because the last video, the last property I've taught you guys about determinants, it says that if you take any determinant and like rewrite it's one of its rows or columns as the sum of another row or another column as it is, or that row or that column multiplied with a constant, so the scalar would result in the same. So combining these two properties, when you're trying to solve any determinant that looks very complicated, you can just try to make it so that like if you can what we should basically be doing is you should try to make the rows, any row or any column consists of as many zeros as possible. So let's say you got a 3 order determinant, you will try to rearrange the row in such a way that you get to a point where every element, or if not every, that at least majority of the elements are zeros. And if you get to do that, then the determinant is going to become much less complicated, because then you can evaluate this that determinant from the perspective of that row or that column. And of course, you are going to you will have to deal with a lot less quantities, because elements are going to become zero. So the only ones that did not have become zero, you just only have to consider take them into consideration, and that is just gonna make your computation lot easier. Okay, I think I'll have to do an example as well. Wait a second. I have to visualize this. Let's say we have been asked to evaluate this data. What does it say? If we evaluate this one, B plus C, A, B, C plus A, C, A plus B, B and C. We have been asked to evaluate this one. Now you can get it done in the old school way, like calculating the determinant, evaluating this from the perspective of any row in any column. But that process is gonna be really very complicated, because you'll have to take into consideration all of these terms, and that is gonna make things a lot more complicated. Instead, what you're gonna do is you're gonna to rearrange this in such a way that as many elements as possible become zero. Okay, so let's try to minus this one, this second row from this first one. Create this one as the difference of these two rows. This will become B plus C. So actually what I have done here is subtracting this third one from the first one. So minus A minus B, and then adding the second one here. So this would become plus C plus A, and I have to do it the elements of all the rows are here, all elements here. So the second one would become A minus B plus C. The third one would become B minus C plus A. Then the other two rows would remain the same. C plus A. This one is C. This one is A. C plus A plus B. B and C. Okay. This A and this A could cancel each other. This B and this B2. We would be left. What we would be left with is we're gonna be left with 2C here. And then we can rewrite the second column as the sum of the second one and the first one, and the second one and the third one. So this would become A minus B plus C plus B minus C plus A. So this one would become C plus A. This one would become B plus C. This would stay as it is. I think so. Yeah. B minus C plus A. AC. And these elements would remain the same, C plus A. And this one will become A plus B. You can cancel out B is here, C is here. And this would become this would become 2c 2a b minus c plus a c plus a c plus a a a plus b b plus c and c. Okay. I have to remove this one. It's the original form. Then it would become, what I'm gonna do now is we're gonna be subtracting the second one from the first one and rewriting the first one, first row, first column actually, as the difference between the two. So the first element would be 2c minus 2a. We have CA and CA here, so subtracting this would give us 0. AB and BC here, so subtracting this from this would give us A minus C, and everything else would stay the same. 2A, C plus A, B plus C, B plus C, B minus C plus A, C. Okay. Then this one would become the next step. What we're doing is we are gonna be multiplying this third row with 2, and then we are going to be adding it to the first row. I have told you guys you can do that and the value should be the same. So the first element would have, you would have 2c minus 2a plus 2a minus 2c, 2a plus 2b plus 2c, b b minus c plus a plus 2c, and you will be thinking that why the exam is calculating this looking at notebook, but thinking that this was really hard to grab around. This was really hard to think for me. So I don't want to spend any more time in visualizing this again. I just want to teach you guys what is going on here. Okay. 0 c plus a c a minus c, b plus c, and then 2a will cancel each other, so 2c and negative 2c. And then I can subtract this row from here. You can rewrite this as b minus c plus, you can rewrite this as b plus c plus a minus a plus 2c becomes c. So subtracting this one from this would simplify things a bit. This would become 0 0 a minus c, and this would become just a plus b plus c, a plus b plus c. This would be a plus b plus c, and the other elements would be C, C, B, and A. I can simplify this further, but I think it has been simplified a lot already. Uh, I don't think we should have any problems now, since considering where only we left with is this element of the first column. So if you calculate this value of this determinant from the perspective of this first column, you just have to multiply a plus b plus c with a, and minus that with subtract that with that from subtract c times a plus b plus c from that, and that would give you have to multiply that with a minus c, and that would give us negative c minus a whole square times a plus b plus c. Okay, so you can see that this way this thing has become really complex, really simpler. Of course, I could have done it a bit faster with the few steps, but I thought that explaining each step in detail would be a bit more easier for you to understand. So that was it for the day, guys. If you have any doubts regarding anything I've taught today, then please do let me know about that in the comment section. I will try to resolve your doubts. And in the next video, we are gonna be studying inverse trigonometric functions. Okay, so stay tuned for that. Until then, keep learning. Bye bye.